Alright.
All right, we're going.
Okay. Well, hi, my name's Adam, and today I'm going to be presenting on programming in Java. Okay, so I guess the first thing to get out of the way is, like, what is this Java thing anyways? You know, people talk about it all the time. You might have heard of it. I mean, most people have if they use computers regularly, because, you know, you get that annoying thing that always asks you if you want to update, and you usually click no, or, you know, it pesters you. But you might not actually know what Java is. Well, I'm here to tell you that. It was developed in 1995 by James Gosling, pretty smart computer scientist, at Oracle / Sun Microsystems. And the design goals were that it had to be simple, object-oriented, and familiar. Not necessarily familiar to beginners, but familiar to people who had programmed in other languages at the time, like C. It had to be robust and secure, so there couldn't be a lot of security vulnerabilities, so a lot of Java is designed around sort of minimizing security vulnerabilities. It had to be architecture neutral and portable, which really all that means is that it can't be tied to running on just one computer. It had to be able to run on all different types of computers at once, using what's called the Java virtual machine. It had to execute in high performance, so it had to be pretty fast. And the last one probably won't make a lot of sense, but essentially the last point here kind of just has to do with some ease of use. And all these come from the actual Oracle webpage, if you're interested. Okay, so, you know, I'm going to talk just for a moment about Java internals, not because, you know, you really need to super duper understand this to program in Java, but just because, you know, it helps you understand, like, the workflow of programming in Java. So really the way it works is you start with your .java file, and that's a source file that contains, you know, your Java syntax, which is your actual program, the actual logic and structures itself. And then you have the Java-C compiler. And the Java-C compiler, Java-C stands for Java compiler, basically takes that higher level source code and it translates this into this lower level bytecode, or called a .class file, and those are like lower level instructions that are easier for a computer to understand. And then finally, you get this big thing here called the JVM, which allows Java to run on all different types of operating systems, so like Windows, Linux, and Mac, it all works. So that's sort of the big workflow for Java. So really, the goal is that, you know, you have .java files, which become .class files, and then .class files are what you run. So that's kind of
And .java files are human readable. .class files are not.
Yes, that is
If
a
you
very
ever
good
open a
distinction.
.class file,
It will look like
like
gibberish,
complete
yeah.
garbage, yeah.
Which is not because it's complete garbage, but because it's being interpreted as ASCII characters that, you know, it's not meant to be interpreted that way. It's meant to be run in a machine. Okay, cool. So you might be wondering, you know, why are we even doing this anyway? Like, how does this pertain to robotics? Well, turns out Java actually is very related to FTC robotics right now. It's the only language, well, not the only, but basically the main language used to write Android applications. And the FTC SDK is really just a big Android application that programmers will put their own code in for moving the robot and such. And the app itself has some facilities for moving motors and getting data from sensors. So yeah, programmers modify the application to add code in order to make the robot actually do stuff. So Android and Java are kind of on good terms. Sorry, that slide is in the wrong order. So here is sort of a high-level overview of, in case you don't know, like how the control system works. So you've got two Android phones that are connected to each other over Wi-Fi, and then you've got your Java Android application running on this phone, which is the robot controller that the programmers modify. And then that talks to the robot and makes the robot do interesting things. So I will go back to my previous slide. In order to do this sort of tutorial, we're going to have to go and set up a virtual machine at this website, codeanywhere.com. I'll go to it and you can see it in the URL bar here. So codeanywhere.com is a website for basically programming online. And what it allows you to do is allows you to sort of spin up little virtual machines, or basically other, I mean, you can think of a virtual machine as like an emulated sort of fake version of a computer. on different servers in the cloud, so that you don't have to have all your Java environment or whatever set up locally. And one of the hard things about Java is that setting up the editor is almost half the battle for actually learning the language, because it takes a lot to set up. So you're going to want to create an account. I have already created an account here. Basically, creating an account is pretty simple. You just put in your email and a password. And the one thing you have to be careful of is it will send you a verification email that you have to follow, or else you won't be able to. It will block you out of doing some of the steps that I'm going to show here. So I'll just wait for a moment for people to do that.
Now, the first screen we're given though is a connection wizard.
Yeah.
Should we just get out of that?
Yeah, why don't you get out of that for now? Well, actually, sure. You can just add a new connection by clicking File, New Connection anyway. So.
Okay, so we can just get out of that.
Yeah, I just want to show the
All right, so we have a blank screen.
Excellent. Okay, you can start again. All right, so once you have verified your email and have logged in, you should see a kind of screen that looks like this, which is sort of your workspace on this website. So the first thing you want to do is click File and then New Connection. And there's going to be a big drop-down list here of a lot of different things. And you're going to want to click on the first one, which is Container. And this will bring up a connection wizard. So as you can see, this site allows you to run all sorts of cool virtual environments. But the one we are going to want to be working with right now is Java. So we're going to search for Java. And it will give us this error because of probably some poor website design there. But what we should see is, well, I guess. Oh, whoops! I actually put Java in the wrong place. Never mind. Good design. It will show us the error, but it should give us a choice between these two, and we've got Ubuntu or CentOS. We're just going to choose Ubuntu for now, and we should name it whatever we want. I'm going to name mine Java for now, just because that's simple, but you can name it whatever you want. And now that we have clicked on that, we'll just hit create. It will, take a while because it's creating on a remote server. Who knows what it's doing? Maybe spinning up some kind of Docker container or something. But once it is created, this dialog will show that. Are you guys all good on creating the container?
Yep, it's working.
Great. Yeah, it should take a while to deploy. In the meantime, I've shared a folder with you full of some Java examples. There are a lot in there. Mostly, the topic is mostly in the name of the file. Cool. So now we get this little nice page here, and it will even show us where our container is actually running. We can SSH to it if we wanted right here. But this web interface actually allows us to SSH anyway. So what we'll do is we can get out of this, and it's already opened a terminal. So this is our terminal. We're going to be doing some work. Basically, the idea here is you create a file called maybe. We won't even make this a code file. Let's just make it plain text. Let's say this is some text or something, and if we save it as maybe, who knows, text.txt, we have to click on a connection, which in this case is Java, and then if we hit save, and you don't have to totally follow along. This is just an example. The idea is that it will upload it to our remote server. And if we go back to our console and we type ls to list the current files, as you can see, text.txt is now there. And we could make sure it's there, which it is if we print it out. So some commands you might want to know for working in this sort of environment. ls So you know, ls and then enter to run ls, which is list files in directory. And then you might also want to know how to clear your console if you got a bunch of text going on. So that's a pretty simple one. That's just clear. Cool. So with that out of the way, I'm actually gonna. One other thing. If you somehow get exited out of your SSH connection, which I guess I'll have to close this, you can easily relaunch it by left-clicking on the connection and clicking SSH terminal, just in case you want to know. Okay, so that's kind of our whole Java environment here. So we're going to go back into our presentation and continue. So I'm just going to give a little outline of kind of what this presentation will cover and what some of my examples cover. So really, I'd call this like the basics of Java. So you've got variables, which are basically like how you store the state of your program, and more specifically, like how do you deal with values that you don't know, like when you're writing your program. Like where do you put those? That's what variables are really for. Functions are kind of about like how do you reuse code. So we'll probably explain more about that later. Primitive types and operators. So Java is what's called a statically typed language, which means that every piece of data actually has to have a type. And that's a really important piece to understand if you're going to want to program in Java. And then operators are like how do what are the basic things you can do with those primitive types. Control structures are kind of the basis of most programming, like how do you make decisions in your program, how do you repeat bits of your program, etc. It's sort of what makes your program smart. And then arrays are a way of storing a lot of data at once, which are useful in some cases in robotics. And then finally, if we have time, we might talk about some classes, which are basically like a bunch of types put together. And that's called object orientation. Cool, so we're gonna jump right into the core Java syntax. So this is your first Java program, and I'll explain a little bit about what it does. But I think the best thing to do would be to go into the folder I shared with you guys, and there should be a first Java program in that folder. It might be slightly different than this one, but it's the same basic idea. It should look pretty similar to this. And I think it's I can check if you want, but I think it's
just called, yeah, there it is, first Java program.
Yes, yeah. There you go. First Java. So what you're gonna do here is just copy this whole file, Control C it, and then go back to your editor and I'll give you some instructions on what to do. We'll close out of this file for now. So to create a new Java source file, we're going to create a new file, and we're going to copy and paste paste in our actual code.
File, new file?
Yeah, sorry, file, new file.
And then just
Yep, file, new file, and then it should give you an untitled file. Okay, so this is kind of one of our first lessons about Java. So if we were to go back here, we can see that Java programs, they start with this sort of public class here, and that sort of signifies the start of the program. And the whole program is wrapped in these curly braces on either side, the outer ones. And the name of the class, my first Java program in this case, has to be the same as the name of the file. So if we have a class, if this was in a file, then it would be my first Java program.java. And that's very crucial because it will not, Java C will not compile it if that's not the case.
So should we save the file we have here as that?
Yep. First Java program.java. Sorry, the name is slightly different, but so first Java program.java. Click on, and then you have to click on your connection to upload it to, and then we just hit save. Cool, and it'll syntax highlight for us. So let's jump on into our console over here. Has everyone saved this? Cool. So we'll jump on over into our console. And you can type ls if you want. Oops. To see, and yeah, it is here along with our text.txt file from earlier. Okay, so let's compile our first Java program.java using Java C. So to do that, we're going to run Java C and then the name of the file.
You can also do it, Cal, you can do a tab complete, so you can say like Java C and just put the letter F and then hit tab and it will complete it. So you don't have to type it all.
Yeah.
To type that whole thing. You
Check.
don't have, you can just type Java C, F, I, and then it will complete. If you hit tab, it just finishes the whole word.
Yep. It looks through the directory to figure out matches. Cool. So if we run this command and there were any errors, then it won't show us any output. But that doesn't mean it didn't do anything, because if we type ls to check out what files in the directory, oh, now we have first Java program.class. That's the compiled sort of version of it that we're going to run. So you might be wondering how to actually run this file. Well, you use the Java program, not Java C, and you're going to want to type Java and then the name of the class file, but you don't want to include the .class. So you're just going to run Java first Java program. And if you try to autocomplete, it will look for a file and put a dot at the end, but we don't want the dot. We just want this. Can everyone type in this command? You can run it. So if you run it, it should print, this is my first program in Java.
So I did FI.
And then hit tab. There it goes. Java C. What do you got?
But
Java
it
C
said no.
file not found.
Did you save it?
Yeah.
Oh, Java C not found? Or does it have Java C at all? That'll be an issue.
Java C file not found. Wait.
Can you type Java C and just see that it works?
Yeah, that's there.
Okay, good.
Java C. Oh, it didn't. Should be declared in.
Oh yeah.
There's just a first Java. That looks pretty good. What's did you? Let me see.
Go and check it out.
Yeah, go ahead and look at that. What's the error? What was the error we saw? Like the terminal. First Java error class is public. So we declared it a file name to first Java program, not Java.
Here, let me see that. Oh.
Oh, it's just
I can't spell today.
spelling today.
That's why. Originally, I spelled program with a J, so it's actually approved.
And then we'll just rm the other file because we don't want that. rm-rf. Actually, just I'm so used to typing rm-rf. Cool. And then now we'll just Java C first, and then Java first.
Oh.
All right. Cool. So, gives you a little taste of programming in Java, but of course there's a ton more we can do. So, for the moment we'll leave this up, and yeah, I guess we'll explain a little more about what's going on here. So, one of the first things to understand about Java is what a comment is. It's a really basic thing that comments are really all they are just things that the Java compiler, Java C, ignores when it reads through your file. So if it sees anything, any line that starts with // or any like bit of text that's wrapped in /*// then it knows that it's not going to interpret any of the things within that as actual Java. So usually comments are actually used for documenting your code or explaining maybe some kind of algorithm that's not particularly easy to understand if you aren't kind of in the mind of the programmer. So it's usually how programmers sort of, I guess, express kind of what they're thinking while they're writing the code. And then, yeah, we'll go here and talk about the structure of Java programs. So, yeah, you've got your public class, which is like the whole file in curly braces. And then you've got your variables and methods, which I have a comment that's describing what would be there between this and this public static void main. And then what is public static void main? Well, that is the code that will actually run. This is what Java starts. And we'll talk about what main actually is later, but it's actually a type of a function. You may be wondering about this string args. So one thing to understand about the way programs run in the command line is that when you run, I'm just going to type a sudo program. So let's say you have a program installed called program. The things that come after are usually called arguments or parameters, and they are captured when you run the program. So Java will actually capture. So let's say I was running a program. Let's say I was running Java, let's just call it class. Let's say that was the name. And it took two parameters, maybe 4 and 5. These two parameters here would be stored in this bit of data here, this string args. Just if you're curious about that. It might not make a whole lot of sense right now because we haven't talked about arrays, but this is for capturing additional data to give the program when it starts. Cool. So we're going to start off by talking about primitive types. So Java, like other programming languages, does have a lot of built into the language. So basically the idea is to let programmers do the basic mathematical and computational things they want to do without having to get a bunch of other people's libraries or code. So let's talk a bit about this list of types here. So I guess this is sort of divided. There are integers, which are these 4 here. These 2 are floating points.
Decimals.
And then, what did you say, sorry?
They use decimals.
Yeah, sorry, they use decimals. And these 3 down here are sort of other more interesting types that we'll talk about last. So I guess number 1, we'll talk about the byte. I just put the actual size in this column just in case you're interested. But it's basically any number from negative 128 to positive 127. So pretty small. But if you have to store a small number, it's great for that. Short is a bit bigger. It's 16 bits instead of 8, as a byte is 8 bits. And that's any number between negative 32,000, 33,000-ish, and around positive 33,000. But you hopefully don't have to worry about those limits too much unless you were doing some big numbers. Int is even bigger. You have to start expressing it as an exponent here, 2 to the 31, and long is even bigger too. Still, it's 2 to the 63. So.
Can I make a mention, Adam?
Yeah.
The reason is that this is important. This has been important at times. Is that when you would compile when the program runs, it saves memory in this size. So if you're using just numbers like 1, 2, 3, 4, 5, 6, and you happen to instantiate them all as long, that program is going to hold on to more memory in the computer. So it's not very efficient, right? So it kind of seizes memory. It says, I'm going to run this program, and I need this much memory to run.
Yeah.
And it knows that by what you instantiate it as. I would say, wouldn't you say, Adam, that most of the time we just do everything as ints?
Yeah, but if you really care about space savings, so let's say you had, for theoretical purposes, if you had 3, let's say you had 3 things declared as a short maybe, but you were only using numbers between negative 128 and 127, then what you would actually get is half. You would have the storage space you needed if you were going to use a byte. So I guess what you're saying is a very a good thing to think about, because if you don't need all the storage space that this provides, you can have significant memory savings in your program if you think about this. However, for the average person running a program, they probably don't have to think about that too much. But yeah, it's absolutely true. If you're really in a resource constrained scenario, it could matter. Good point. Okay, cool. So these are all integer types, ranging from pretty small to pretty big. But you can't always store things in ints. You might need some sort of decimal. So if you wanted to store, for instance, the value of pi, you can't really put that in an integer because it's not an integer. And you can't really store it on a computer fully either because it continues to repeat. But you could at least store an estimation of it in maybe a float or a double. So a float is a single precision 32-bit floating point number, usually around 9 digits of precision. A double is a 64-bit floating point number, which has a lot more digits of precision. So generally, if you need to store a big decimal, you're going to want to use a double. If you need to store just a few points after the decimal, you should probably just use a float. That's sort of a good rule of thumb. And then we have a char here, which is sort of the building block of like strings in Java, which we'll talk about in 1 second. And that's literally just one character. So it could be A or I don't know, Z, or uppercase A or lowercase or uppercase Z. Basically,
you can store a number in the char, but it's not interpreted as a number. Am I right about that?
Well, if you were to like, let's say you stored 97. Well, what is
About
97 A in ASCII? I don't know. Well, first of all, are chars I don't think they're Unicode in Java, right? Okay. Well, anyhow.
Anyway, it doesn't matter.
But yeah, it's true. Like you could set a char equal to a number, or no, sorry. If you could cast a byte to a char, but yeah,
Right.
I think if you wrote char A equals like 127 or something in the program, it wouldn't work. But I don't know. I can test that. And then a string is just a sequence of characters. So it could be like, I don't know, some string like I am not an alien would be a valid string. That sentence. That is really random. And then finally we've got a Boolean value, which is incredibly simple data type because it literally only has 2 states. In fact, it could even be represented as a bit, and that is either true or false, 1 or 0. So, and Booleans often don't make a lot of sense when you're studying out, but you'll realize later that basically like a whole lot of the operations you actually do when you're programming involve Booleans, but you just don't really think of them that way. Cool, so now that we have that out of the way, we can talk about variables. So a variable has a type and a name. So the basic syntax is type and then name. Pretty simple. So in this case, this variable is a string, because we've said it's a string, and its type, its type is a string, and its name is type, which is a little bit confusing now thinking about it.
You could have called that name anything, right?
Yeah.
String, it could be string car name Subaru.
Exactly.
The word type could be any word. It's your variable name.
Yeah, exactly. And then this is the top speed, which is the top speed of this car. I'm just thinking about a car here in this example, but variables could store information on anything. You've got the price, which is another integer, though it could be a floating point if you wanted to have cents on the end. And here's an example of you can do a variable declaration on multiple lines. So in price equals 22,000. The one thing you want to be careful of though is you don't really want to use price if you haven't actually set it to something. You want to be careful because you can get some interesting behavior when that happens. So that's kind of the idea behind variables. So I've got a little, exercise in my Java examples folder here. I'll go back into the main. So I think I've got one that's variables.java. Here we go. And I'm just going to copy and paste out of this file. It's very simple right now, but we might add to it. And then we're going to go through our file, new file again, and paste it in. Cool. So now I'm going to control S this. And what I should show is that the name of the class, the public class, is variables. So, Callie, if we want to save this file, public class variables, what does the name of the file have to be?
Variables.
Yeah, .java, but yeah.
Spelled correctly.
Yep, exactly. So if you don't spell it correctly, you'll get an error. All right, and of course we have to pick where we're going to upload it, which is our Java connection here. And let's save. Cool. So this is a very basic, this variable declaration here, long x. It's not very descriptive. You don't really know what x is. People often use one-letter variables for numbers, but in this case it's sort of hard because it's an example. But you really want to name variables in a descriptive way. So like maybe, let's say we wanted to create a string variable. So we're going to use the type, which is string, and then we'll call this. This is sort of but we'll call this string var, because it's a string variable. And we're going to set it equal to this is a string, and that's that. And one thing to note is that basically all of the statements in a Java program, which is basically all the code you're going to write, they have to end with a semicolon, except for some of these like sort of declaratory statements here. This ends with a semicolon, this ends with a semicolon. It's common in a lot of languages, but you kind of have to know that because you get a lot of annoying semicolon errors. Cool. So right now we've got this system.out.println, which we also saw in our first Java program. And all that does is it prints a string out to the screen. So in this case, this string here, this is my first program in Java. In this case, it's this string here. And we'll talk a little bit more about how this works later, but this plus operator essentially takes the value of x, and it adds it on to the end of the string. Because there's a space here, and then the variable is going to get added on at the end, so it sort of pops it onto the end. So if we were to print it out, it would be the variable x has colon space, and then the variable, which is the value is 123. So we could also print out the value of our other variable. So to do that, we're going to use the same thing, system.out.println. And we need to make sure we have double braces or double parentheses here. And we'll say the variable string var has value, and then we'll have a space on the end here. And we'll add on string var. Whoops, I guess that autocomplete didn't work. String var, perfect. Okay, so now we're going to print out the value of x and the value of string var. But before we run this, we could do a little more too. Let's make a variable, one more variable of a different type. Let's say it's a longer, let's say it's a floating point number, but it's a longer one. So we're going to say a double long decimal maybe equals, and then we'll just maybe think up like a long decimal, 3.124569123. And maybe we'll add a few more. This is just really arbitrary, but I'm just showing that you can fit a long decimal number into a double. Cool, and now we can print this guy out too. System.out.println variable long decimal has a value, and this is just to make sure we know what variable we're printing out. And then and the IDE will give you suggestions if you start typing a name of a variable, and if you hit enter over the suggestion you want, it will auto-complete it in for you. That's just a little tip. Cool. So if we have this all typed in, do you guys have this typed in? Okay. Alrighty, cool. So if we save this up and go over, I'll get to this example here. If we ls, we should see variables.java file. So we're going to java c variables.java, and you can autocomplete that with tab. Cool. And then we're going to java variables, which should be the name of the class. And there we go. So this is our long value, 123. The string var, this is a string, and this long decimal that we typed out, should be exactly what we expected. Cool. Does anyone have any questions?
No, I'm just. Kelly's infecting me with bad spelling. Decimal.
Did it run for you?
There's just the typing.
There we go.
Oh, okay. I can go back to the file if you want.
not text. There you go, just hit it. And now, if you want to say ls, you'll see the variables dot class right there. Right? So now Java variables. What's that? Can I VI this?
Did you spell it wrong?
No, it's just an old file. Okay, so now just run Java variables, because that's going to run that class file.
Okay, why it doesn't let you just put the class at the end? It's kind of annoying.
It is. Print it out.
Cool. So yeah, and you're welcome to. Did you get something that looks like this? Perfect.
Yeah, the reason you don't use the dot class is because you can put multiple classes in a file. You can actually, what you're doing is running an object, and will search through those you're referencing an object, not the file.
Internally inside the file. So we'll go through that.
That's what it.
Oh, there's probably some header in the bytecode or something.
Yeah.
Okay. Cool. So, what was I gonna do? Okay. So that's variables. So I'm gonna jump into my presentation and go to the next slide. Operators. So this is how you do math in programming. So
It's just Willie's two favorite things.
So, let's talk about what you can do. So there's this equals here, which we saw earlier, and that's really just for assigning to variables. So one very important distinction that people often get confused on, when they're learning programming, is that equals is very different than equals here. So equals means you take the thing on the right and you put it in the thing on the left. That's literally all it means. Equals is a little more complicated. Basically just compares the two values on either side of it, and if they are actually equal things, then it is true, otherwise it's false. We'll talk a little bit about these booleans in a second. Okay, so these are pretty self-explanatory math operators. You might have run into them too, just, if you've ever had to like type a math formula into a computer before. And most programming languages have these sorts of conventions. So plus, minus, times, divide. The one thing that you might not have encountered before is probably this little percent sign here, and that's called mod or modulus. And the idea behind it is it's really just the remainder of a division. So one example that's pretty easy to do is if you do like 10, we can figure out like what's 10 mod 2 maybe. So this is a pretty easy way to figure this out is, okay, well what's 10 divided by 2? Well, you probably know what 10 divided by 2 is, it's 5. So, and there's no remainder. 5 goes in 2 times plus nothing else. But let's say you wanted to, so as a consequence, because there's no remainder, then this guy is the same as 0. Or if we're going to do programming speak, we'd say equals 0. However, if we were to do something that does not go into 10 evenly, like let's say 3, well, what's 10 over 3? It's 3.3 bar, or it goes in 3 times 9 plus remainder 1. Bam. So that remainder is what the mod captures. So this should be equal to 1. So that's basically how mod works. Now, an easy way, or one way that people use mod a lot, is to check if a number is even or odd. So how do you know if a number is even? Well, 2 has to go into it evenly. So if you have a number, let's call it n. N is even if n mod 2 is 0. So that's if it's not, then it has to be odd. So that's an easy way that people check for even numbers. Cool. So and these other ones here are all what's called Boolean operators. So these guys give back actually like a math result, like the remainder or the actual value of the division or multiplication. You get the idea. These guys give back a true or false value, and they take 2 like operands on either side. So I'll just talk about a few of these because the pattern basically extends for the rest. So let's see. Let's take not equals, which is exclamation equals. It's a little confusing. So if you have 2 things, like let's say 5 and 6. So and you write 5 not equal to 6. This is true because 5 is actually not 6, unsurprisingly. Yeah, so this is true. However, 5 not equal to 5 would be false, because 5 is actually equal to 5. It's not equal to 5. It's not equal to 5, which is actually something you could write. But anyhow, now we also could do the opposite. We could say, okay, how about 5 equals 5? This is true, but 5 equals 6 is going to be false, because hopefully this makes sense. It's just sort of the reversal there. And then these greater than and greater than are equal to, that's what these mean. So taking our two numbers, 5 and 6, if we were to say 5 greater than 6, well, sadly that is not true for us, so that's going to be false. But how 5 is less than 6, so this is true. And then 6, for instance, is not greater than 6, but it is greater than or equal to 6. So this is just how these operators work. Pretty self-explanatory there. And then one that people generally have not encountered before programming are these guys here. We're not going to worry about the ternary operator. In fact, probably shouldn't even be taught about the ternary operator at all. People write some, abominations with that.
Yeah, they're horrible.
But conditional and conditional or. So these guys are basically, so I guess the way to do it is return, and I'll just say this is like what it gives back. So and gives back true if, so let's say, here's going to be right. So if we have two sort of conditions here, A and maybe B. So A and B was only true if both A and B are actually true themselves. So this is true if A and this is where the name comes from, and B are true. If one of them is false, then it won't work, and if both of them are false, it also won't work. Or is a little less exclusive there. So or is true if, I keep writing this wrong, but so let's say A or B, which is the double pipe here, is true if A is true or B is true. It's just the or there. If A is true or B is true. So, right, if we could do a little like truth table. So if we were to do true and true is true, T, F is F, F, T is F, and then F. So I'm writing under this writing here is also F. And then for or, to really just make this clear, if we were to do T and T is true, T and F is also true, or F and T is true, but F and F is false. Cool. Alrighty, so that is the idea behind these Boolean operators here. And then we've got one more at the end, not, and that just flips the value of a Boolean. So if I had maybe a variable b, and I said b is true, then not b would be the same thing as false. So you often use the not in programming when you want to check that something is not the case. So let's say I have a variable called maybe b again, and I'll, I guess, quickly introduce an if statement really fast. But basically what you do is if not b, so you want to make sure b is, so if b is actually false, then you might do something. And I'll explain a little bit more about if statements, but this is just a quick example of what you might actually use the not for. So it flips the value so that you can use to check if a variable is actually false. Because most of the things you use to check, like the values of Booleans in Java, are always looking for true values. So this is a way to make them look for a false value, basically. Okay, cool. So that was a lot about operators, but I've got a little thing here that has some operators. So we've got logic operators here, which we could open, or math operators. Let's open logic operators for now, because I think this will be make this nice and clear. So let's copy this logic operators folder. And we can predict what these are going to be. Cool. You guys found the file?
Yep.
Okay, cool. And we might get into some more involved examples here. So. Okay, cool. So logic operators. We'll save this. We have to save this as logicoperators.java. Cool. Click on this. Save. All right. So what we've got here are two Boolean values because they hold true or false. This guy B1 is true, B2 is false. We can theorize what we will expect these to print. So this is we're going to add. This is a little confusing because we're adding this onto the string, but essentially this value B1 and B2. What do we think this is going to be? So if we substitute in B1 true, B2 false. So true and false. What will that be?
False.
Great. B1 or B2?
True.
Great. Okay, and then this one, what do you think it's going to be? So we've got,
True.
yep. Yeah, because you've got true and false, which is false because not both of them are true. But this false value is reversed to be true. Cool. So if we print these out, we should get just that.
Why is only one of them false in this?
Hmm? For which one?
Like, for the third one, it looks like it would make both of them the opposite.
It doesn't distribute. That's a good
Well,
point, actually.
It's actually, there's a law for distribution of it, but it doesn't distribute in the same way.
There
is what I
is, that's
think.
true.
It's
It's like you do the in parentheses first, right? So you first evaluate what's inside.
if you're interested in how it's called, I actually just learned this recently, but because you often don't think about this, but so if you have A and B, or B1 and B2, actually we'll just do it because that's the name. That is the same. The way it distributes is not B1 or not B2. So it flips this from an and to an or vice versa if it was an or. So in this case, we can print this out and demonstrate, if you're interested, that this is the same as not. And if you think about it, it would be the same because not true is false, not false is true, and true or false is true. Again, that's really nerdy, but yeah, that's the way it works.
You can. Yes, there are
Did
rules.
you lie on your whiteboard? Because it says false and false is false.
No, I
No, false or this is true. That would be a false or true.
false
which
or
is
true is true. Yeah.
Because it switches. It's a weird. I mean, you don't need to worry about it, but it's just when you distribute it, you switch it from ands to ors. But I think the easiest way to think about it is just look at the parentheses. What does the parentheses return? It's false.
Yeah.
The opposite of false, true.
Yeah.
That's the easiest way.
And if you really think about under what conditions this statement actually returns true, what it returns false, then this makes perfect sense. But we don't need to think. We don't have to do that right now.
Well,
Okay.
what I wasn't getting was that it turns ands to ors.
Yeah, well, it's not an obvious thing. I mean, it's not unless you work with them a lot. That's not obvious, but it
Yeah.
does.
And you really don't have to think about it when you're nodding like a really complex expression where it would be easier to think about without the not distributing, which you don't see a lot. And usually if you see that, it's probably, could be written in a better way. Anyway, so I did run into that this summer a few times in some Java code bases. So yeah, so that's the idea behind that. So not reverses stuff. So are you guys good on logic operators? Or I guess
Mine ran okay.
Excellent. So I guess we will move on here and learn about some functions, which are a huge part. Okay. So we keep seeing some of these little these names that have these parentheses after them, and what this is called is a function. So I've defined a function here that doesn't really do anything except print I am in a function. So we'll break it down a little bit, specifying where it is, but it is a function. So how would we call this? So calling a function is how you should make it run. And you just type the function name and then left and right parentheses if it does not have any arguments or anything inputs. So that's like the basic function. And then we've also got some more complicated examples of functions. So sometimes you do want a function with inputs, and you think we have functions a lot that might have inputs. Like for instance, this guy. Let's say you want us to have a different greeting based on like the name that someone gives you. So that's great because you can declare what's called an argument or a parameter. You can think of an argument as like arguing with the function's behavior, like arguing with the way the function works. That's a kind of fun way to think about it. So basically, an argument is sort of like a variable declared in the like function like declaration here, and so you can use whatever this is in the body of the function just like a normal variable. So you can system.out.println hello, and then here's the plus operator again, name. So this should print like hello, and then whatever you put in here. So how do you put something in? Well, we can either pass a variable that's a string or just a string itself. So if we print greeting Jacob, this should print hello, and then, oh, this gets substituted in hello Jacob. Are we good on this? Okay, cool. Now we'll just talk about return values really quick. So functions often, like most functions actually, need to give back a result. So here's a function that actually like does that. It's very simple, kind of a contrived example because you would never make a function that adds because you can already do it. But here's int add, so we know that this function gives back an int. And we've got their two parameters, int a and int b, and then we return the value of a plus b. So that's just giving the value back. So how do we actually like store that value? Well, if you take a look at this little line of code down here, int answer equals the value of add 5 and 7. So answer should be 12, but the idea here is that basically you can think of like functions that return values as giving back a value and like store, and then it will be stored in the variable. So this function evaluates to this value basically. Alrighty. So we can do an exercise on functions if you guys want, or we could just keep going.
What do you want to do, Calvin? Let's.
Or we could wrap this up too. Like we've been going for a while. So.
Yeah. What I was saying, just for the video, why don't we do one thing with using functions?
Okay.
And I'll wrap. Then we can wrap, and then you can either keep going or not. Or, I think functions are, since most of our code has functions in it. Let's do one of functions.
Yeah, sure. And
just test it out. See what we.
Okay, so I think I've got an example in here, but if I don't, we can just write one up really quickly. Let's Control F for something. Yeah.
Fancy.
No, I guess not. So okay, what I might do is just make a new file then and just do a little demonstration.
Yeah, let's just do it by hand. This will be. We'll do this as our last one for the video.
Cool. So functions. Let's first of all let's create our public class, our program called functions, and we'll open the braces here.
Can we call it something other than functions? You shouldn't call classes or functions functions.
Okay.
Can we call it like function test or function fun, or
how about fun functions?
Fun functions would be great.
Okay, so if we've named it fun functions, or whatever you want to name it, funfunctions.java, if I can type, and we're going to save it to our little Java virtual machine, or Java container. Okay, cool. So this class is going to have some functions in it, and when we're thinking about functions in the context of a class, and a class is sort of, in this case, our program, but you can think of it as like a big grouping of like behavior and like data, then we call it a method. So I'm going to mostly call these methods. Cool. So let's make a function that, oh man, what's a fun thing we could do?
Well, we could do the name thing with strings, or we could say like have, yeah, let's just do greetings with names.
Sure.
Or should we have a return variable?
Yeah. Sure.
Let's see. How about something that says your name and your age? So it passes a name,
Sure.
and it returns the age. Or, you know, like
Returns an age? Okay.
like returns the age of the person or something.
Okay. Sure. How would we figure out what their age is, though?
Let's just.
You want them to pass in the age too, you mean? Or?
No, I guess we don't need to do that.
I mean, we could have like a lookup table of names to ages.
How about assign them their lucky number, return their lucky number, which is a can we?
Yeah, we could do something like that.
Can we input a math function in this?
Yeah.
A random function?
Yeah. Okay, so before we do this, then what we're going to do is it java.util.random? I don't know the Java. I think it's java.util.random, right? I can look it
I
up.
think it's not math.
.math, okay.
I think it's in the math.
Java.math? Is it? I didn't know Java.
Well,
Okay.
never mind. Let's not do it then.
Oh.
Let's, if we don't know it.
Here, I can look it up really quickly. No, why is it autocomplete to JavaScript? Math.random. Okay, it's just math.random. So what it should be is...
No, that's the function. That's not the library.
Oh, yeah, you want to use the random here. No, dang, they don't have to show the library. Okay, well.
Don't worry about it. Don't. Never mind. Never mind. Let's just.
Oh, java.util. Oh, okay.
Okay, Java.
We're good. Never mind. Cool. Or we could do, yeah, we'll just do this for now. So, okay, cool. So we'll have this return a string, and we'll say lucky number.
It should be a int.
Oh, you want
Or-
to return
or
a
a
lucky number?
float.
Okay, sure.
Something.
We could return their name plus lucky number. And we'll say string name. Okay, sure. Then we won't need to really use a parameter then, right?
Sure.
Okay, cool. So we're gonna say, well, I guess I have to explain, but random r equals new random, and then that should return a number between 0 or, actually I have this documentation open. Next, I guess just next, maybe just in a random int.
Next int. No, but that's going to be give you uniformly distributed between 0.
Between 0 and the specified value. Oh, that's okay.
Yeah,
Yeah.
that's
So
okay.
let's say it's like between 1 and 100 maybe, or 0 and 100.
Yeah.
Okay, cool. So we'll say int lucky, which is a variable, is r dot next int, and we'll say it's 100 is the max. And now we have this variable, and we want to give it back to the user. So we will type return lucky. Okay, cool. So now you guys can follow along if you want. I'm just going to make a main function here that calls this. So we'll say, let's say int our number, maybe our lucky number, equals and we'll probably need to make this static, actually. I'll explain what this does in a second. Let me just make sure this runs. Maybe it might not.
I think we have a couple connection issues in here.
Yeah, probably. Cannot. Oh yeah, I probably. Oh really? Okay. I don't know why I needed that. Oh, okay. Mine worked, but
Here, go back to it.
I also made this static.
Made what stack? Oh, why does it need to be static?
I guess maybe it doesn't. I don't know. It made more sense because we're not like making an instance of it, but I guess probably doesn't need to.
Oh, I see what I did wrong.
I mean, should still compile anyway. Yeah, that's why. Yeah, because you can't. Oh, I had a feeling.
What, it has to be static?
It has to be static because if you think about main as a static, because this
Oh, yeah,
this would be
yeah,
an
yeah.
instance. This
Yeah,
would be an
of course.
instance.
You're right.
So this function probably doesn't even exist before being instantiated. Anyhow, so yeah. Okay, I'll just leave you. You guys can copy this down if you'd like. How are you doing,
That's
Kelly?
still-
Yeah.
Travis, I'm still doing problem. Oh. Okay, I think. Alright, well, I'll get that working and finish this up.
Cool. So I will run this, and I had an error there, but hopefully we should. Bam. So that should be a class file now. And if we ls, we see funfunctions.class. Great. Java fun functions. And apparently it's 27 today. But
Hey,
to
yeah.
demonstrate that it could be something different, oh, now it's 1. Now it's 94. Now it's 68. 93. 78. 23.
Nice.
So yeah. Random numbers.
Cool. Alright, I'm gonna wrap this
Wait,
up.
mine didn't like.